Hi, welcome to another meeting of iChime. In this meeting, we featured special guest Dawn May. Dawn is an IBM champion and one of the top system performance gurus in the IBMi community. Amazing. She was able to share with us many things. We call this meeting Performance Potpourri, and that is not an understatement. We covered such a large swath of performance things, data collection, amazing stuff, how to use Navigator to create graphs that help you interpret what's going on in your system. And I can assure you, watching this meeting, you will definitely learn something on how to improve performance on your IBMi system. Thank you, Dawn, very much for your time. Always appreciate it for sure. And everybody, enjoy the meeting. You're going to love it. And see you again down the road. Bye, everybody. Bye now. Today, IBMi Performance Potpourri with IBM Champion Dawn May. Dawn is a leading authority on IBMi work systems and performance management. She has intimate knowledge of the IBMi operating system developed through her distinguished career with IBM. Today, as an independent consultant, she focuses her skills on helping companies troubleshoot issues and plan for the future while teaching them how to get the most out of their IBMi systems. Dawn is also a very large volunteer in the IBMi community, and I'm proud to say that we have done some work together volunteering in the community. And more notably, she is the immediate past president of Common North America. Also the author of I Can blog, which we just showed, and a frequent speaker at local user groups, for sure, an innovator, I might add, and she is the holder of 5 patents, which to me is really impressive. So thank you for that, Dawn. So Dawn, we've gotten the very important housekeeping out of the way, the wonderful introduction, which is well-deserved, I might add. But I do want to kind of turn this over to you because I know you have so much, you've done a lot of preparation here for us, and also you have a lot to share. So I want to just set the tone, just say that, again, Dawn is prepared. She's going to show us a lot of different things on system performance, potpourri, as we said. But we do have an outline that we're going to use, but certainly if you have questions, I encourage you to ask them. What I will say, however, is I don't want to get too deep into any one problem. This is not a consultant. I want to share. I want to have an opportunity for everybody to benefit from Dawn's experience. So the first thing I want to bring up, Dawn, and then you're going to elaborate, please, is on subsystem configuration and job management. Can you give us a little bit what that even means specifically, and why is that important for us to know whether we are admins or even just developers?
So what I'm seeing in the world today is IBMi is really used as a database engine, which it is. It's a database machine. And I'm seeing more and more and more access to the system from ODBC, JDBC, use of SQL, CLI, all these wonderful techniques that can be used to get at the database. But as the system is shipped, by default, we've got chaos because everything JDBC, ODBC, all these QZDA, SS limit jobs are in queue user work. If you're using SQL CLI with HTTP servers, maybe you got a PHP application and it all goes into QSys work. And how do you detangle that? Because when you start looking at a system, and let's say we all have multiple applications, and if you have 5 applications and everything's running in the default configuration, it can be really, really hard to detangle it. And so really one of the first things that everyone should do, and this is nothing new, this is things we've had forever, but break your work apart and use subsystems to separate applications. For example, let's say you have 3 web applications. So you have 3 different web servers and they're using SQL CLI. So you've got all this stuff, these QSQ server jobs and QSys work. You could put each of those HTTP servers in their own subsystem. You can configure the QSQ server jobs to run in this job of the requester, so they'll run in the same subsystem as the HTTP instance, and you can nicely package things up. And when you do that, it makes diagnoses, troubleshooting, investigation dramatically simpler. After that introduction, I am going to share my screen. So I am going to start off by, oh, horrors of horrors, going to the green screen, because we can do all this through Navigator. But I had this up, and I was just keeping this refreshing so my screen wouldn't go away. I'm on the Common 7.6 system. I want to give a huge shout out to Common for making systems available to us, one at 7.4, one at 7.5, and one at 7.6. But I have done my own subsystem configuration. I'm routing work by user profile. That makes it, and I think some of this we all know, but it makes it really easy. But one of the tips is you should give your pre-start jobs, when you route work by subsystem, whether they're pre-start, database server jobs, remote command server, whatever the host servers are, you can give them a job name. And this is a technique that I don't see used enough. And so you can see I've given my database, this is QZDASONet jobs, but I gave them a different name. And this is the secure database jobs. And this is why I said I wanted to talk about that blog of why names matter. As we get into the Performance Data Investigator, we have groupings. And if you want the first part to be unique, so we can do things like generic job name and separate things by user profile, job current user profile. If you give things really good names, then you can detangle this chaos that we have if we're just living with the defaults. And so my remote command server job, and we can do this through the GUI. I just wanted to show the green screen, but we can do this through the GUI. And if we go to Common 7.6, we can see our active subsystems, and we can go look at my jobs in here. And I have QSQ server jobs. I didn't give them a different name, shame on me, but everything else I gave them different names. And what we can do, if we go to under jobs, we can look at our active pre-start jobs. And this is one final thing. We need to tune our pre-start job entries, and we can do that here with the active pre-start jobs. So we can see this is my database server job name. What I want to show on here is I'm part of the Navigator advisors. We have our initial jobs column that's part of this, and we want our initial jobs value to be tuned. So we can easily see this in active pre-start jobs. So we're looking at the one in my subsystem, which I can play with. And we can see my initial jobs is 10, but my average in use is 8. So, oh, that's way too high. We can get to the change pre-start job entry from here and just change it right away. And here's where you give it the name. The default name is the program, QZDASONet. Here's the magic parameter, give it a different name. And then I just tune my entry and I have my own job name, and now I can more easily manage that work. So isolate by subsystems, use good names, and then as we get into the Performance Data Investigator, it makes life a lot easier.
All right, I have a question already for you, Dawn, please.
Okay.
All right, question I guess from a private chat was, can you please explain the difference? What is a pre-start job and why is it different from an auto start job?
Excellent question. So a pre-start job, well, let's do an auto start job first. An auto start job is a job that's set up to start when you start your subsystem. So you add an auto start job entry with the job description for that auto start job entry, and it will run whatever's in that job description, the command or the, I think it's routing data. I can't remember off the top of my head. And it's just run once when that subsystem is started. Pre-start jobs are a set of jobs, and if you go, let's just go look at, as I talk, subsystem descriptions. And let's go look at the Q user work subsystem description. We don't want that one. We want QSys. I love New Navigator, by the way. Love, love, love it. So we can go Q user work. We can go look at the properties. So here we have our auto start job entries. We don't have any in auto start jobs and Q user work, but we have pre-start job entries. And in Q user work, we're looking at typically the host servers are the most common ones. So you've got the database server jobs, remote command, network print. And these pre-start jobs are configured such that these jobs, we'll go just do the change thing. We have, when the pre-start jobs are started, they're started when the subsystem is started. And the number, this initial number of jobs is how many jobs are started when the subsystem starts. And the subsystem wants to keep that number available. So that initial job number is important. And these jobs handle a work request, like they'll handle an ODBC connection request, a remote command request. In terms of database, when that job handles that request, when it's done, the job gets to be reused again. And that's this, oh, I don't see max use. Oh, I have that written down as an IBM idea. We need the max use parameter on here. So we still need to go back to the green screen to properly configure this. So let's go back to here. It's the change PJE command. And it's this max, 9, this max use parameter right here. This is defaults to 200. So this job can be reused 200. So the key points with pre-start jobs is they're a set of jobs that are waiting for work. They handle that work request. They can go back to being reused, not always. Remote command server jobs should not be reused, but database server jobs can be reused, and it eliminates overhead. You don't have to wait for a job to start. A job can be used multiple times, so you don't have to have many, many different jobs for each connection request. Have a story where somebody removed their pre-start job entry. If you don't have these pre-start job entries in place, if you were to remove them or end the pre-start jobs, your connections will still run, but they'll run as batch immediate. So every connection requires a job. I encountered a shop that was doing that, and I said, oh, no, we got to fix this. And it changed performance characteristics of their job or their system considerable. They were amazed at how much overhead, because they didn't have their pre-start jobs set up correctly. I could spend 2 hours just talking about pre-start jobs.
Wow. So there is a degree of persistence here, which is, I think,
yes.
thinking about.
Yep. And the other thing we can get at, this system shouldn't be too bad. And we can look at server jobs. And
to be fair, this is primarily, I think, a demo system, right? So this is not really...
This is the common demo system. And so this is looking at, that's when we want to add. We'll click OK. We get the, and I wish we could sort twice, but so here what we have, and looking at server jobs, and these are watch jobs, but here's QSQ server jobs down here. We can look at how many times these jobs have been used. The watches, if you're using message watches, those are handled by pre-start jobs. These are run 192,000 times. So this one job handled 192,000 requests as opposed to 192,000 jobs. Jobs are expensive. So it's a way to build in efficiency and reduce overhead.
Does that matter? What the job itself is doing? I mean, do you consider that what the actual program is doing or the job is doing? How much maybe I/O or memory might be consuming and things like that? How does that play into this equation?
So the only thing that comes into play for pre-start jobs is the settings in the class object, where you've got max CPU time and max temporary storage. So you could limit how much CPU or temporary storage a job uses. There are parameters on the class object. If you do that, these limits for a pre-start job are for the life of the job, not an individual request. So take a QZDA SOINIT job that handles 200 different requests. If one of them came in there and used and had some sort of a memory leak, and that temporary storage that memory didn't get cleaned up and it got paged out, so it's temporary disk space that's being used, that will persist for the life of the job, not for the life of the connection. And so those totals are for the whole time. So like max CPU time, maybe you had a query that took 10 minutes and you wanted to limit the max CPU, well, that would kill that job. But so typically for pre-start jobs, we don't look at limiting those. If you put a limit in, you put a big limit in. But a big limit's better than no limit.
Sure. So there are two more points I want to mentioned from the chat, you may have addressed one already. Why should the database job only be reused a certain number of times? Did you already answer that one indirectly?
So the default as shipped by IBM is for the pre-start jobs to be reused 200 times for QSQ server jobs, the QDES init jobs, but you can change it. And I have had worked with many shops where we go to 400, 800 reuses because they have a large number of connections coming in. So we up the reuse to go through fewer jobs. So it can be made bigger or made smaller, but I have had good success making it bigger.
And there's one more thing in the chat. It's not so much a question, but I'll just say it out loud. Most people don't know that starting a job does take some time in terms of CPU time. For IBMi, for allocating job details like number, memory, etc. That's why IBM created pre-start jobs. I think it's just a statement of fact.
Yep.
We don't normally see when we submit jobs, as it's mostly ad hoc, but you will surely see it when you run a submit in a loop.
Yes. And I have one of my old blogs out on the iChime blog of blogs on my website is IBMi job structures. So if you want to learn more detail about all these structures that have to be put in place every time a job starts, you'll be amazed. There's a lot of complexity hidden under the covers. 30 years ago, starting a job was a big deal. That's why pre-start jobs were invented. Pre-start jobs date back to V1R2. I can't remember, for APPC communications. So when a program start request, that's where PSR comes from, where PSR waits, that state. When a program, I used to work on SNA communications. So when a program start request would come in, the job would be waiting because it was expensive to start a job, very expensive back in the early days of AS400. Today, look at Power 9, 10, 11. They're massively powered machines. You don't even appreciate how much resources a job takes today, but it's still an expensive operation in the grand terms of things that we do.
Relatively speaking.
Yep, relatively speaking.
Right. So that was configuration and job management. Did we cover everything you think? I do have some questions here. Maybe I think you've answered them already. Can you walk us through? Yes. Why should we create separate? You've already answered that. Okay.
I covered everything that's on my note.
Yeah, I think yeah. Are there any best practices specifically for ODBC and JDBC workloads?
So what I would recommend as best practices is route your work to subsystems as it makes sense in your environment, whether it's by user, if you have an application, but separate the work by different applications, do that. Consider, once you've done that, once you've got work isolated into different subsystems, if you have multiple processors in your partition, consider using workload groups to make sure any application does not ever take 100% of your CPU. So if you have let's say you got 2 cores and you've got application A and application B. If you had them each in their own subsystem and put a workload group on each of those so they could only use one processor, you protect your entire box from one application running amok. Workload groups are great things, but you got to be able to separate by subsystem to really effectively take advantage of them. And I had one other thing I was going to say, and it slipped out of my mind. So,
well, that's okay. Marius is he must be typing feverishly because he already put the link for your blog for IBMi job structures on the chat, so you'll see.
Oh, thank you.
Yeah, very good. This was great, Dawn. Well, let's go on to the next topic, and we'll talk now about weight buckets and monitoring. Oh, and monitoring weight bucket.
Yeah.
And just explain what a weight bucket even is. I mean,
that's exactly what I'm going to start with. So I'm going to the Performance Data Investigator, and I'm going to start with a chart here. I have some demo data I created several years ago. I'm going to bring up this weights overview. This shows me my run weight signature. And these colored bars are what we call the weight buckets. Let's zoom in and make this bigger. And so red is dispatch CPU time. I'm using the CPU. Purple is I'm waiting for the CPU. This is an example of a workload group causing latency, so I could only use half of the partition CPU. But then we've got the seize time. We've got object lock contention. So there's 32 different groupings of weights, and the most interesting ones you'll find in the legend down here. So we can see things like machine gate serialization time, seize time. These are various different types of serialization mechanisms used by the licensed internal code, but we can see our disk time or our page faulting time. And so we call these the weight buckets. There's 32 of them. Another one of my old blogs is about weight buckets. So, and there's also I have a job weighting accounting article from 2013 that's on IBM support site still to describe what these are. But what you want to know, and I've been asked this many, many times, is what if I have an intermittent problem where I see maybe a lot of object lock time, or I have something where I see seize contention pop up? Seize contention can show up like for conflict on a user profile. If you're doing too many temporary object creates and deletes, you could end up with seize contention on that user profile. That's to update the user profile to reflect object ownership. If you create and delete too many objects, you're always updating that user profile, and you could see seize contention. There's lots and lots of scenarios, too far to talk about. But you know what your normal run weight signature is, but if something unexpected happens, it'd be nice to be able to monitor these weight buckets so that I don't have to manually go check and do that. And I have put together a little demo on how we can do this. And relatively easily, and I'm doing it here with Navigator, but if you're using tools like Prometheus and Grafana, or Datadog, or Dynatrace, where you can add in some SQL, you could do the same thing there. And so what I've got here is custom charts. And when I open up custom charts, this is just a new feature of Navigator. It ships with some default charts, and you can have several metrics for a system or a metric across several different partitions. I'm going to just go down here and talk about the weight buckets one. So you can see this takes a minute to refresh because I just opened the tab. But we can see I'm monitoring my disk write time, my page fault time, CPU queue time, seize wait time, and gate wait time. And the magic is just knowing, and if you want to take a screen capture, I'll leave this sit for a little bit, is you just need to know the query on the collection services file to get at the weight buckets. These are tracked at the system level. And so you can see I'm getting them here. I'm going to quickly show you what I do there. And don't complain because I do start SEU. But I have a scheduled job that runs each day at about 1 o'clock in the morning. So collection services cycles every day around at midnight by default. At 1 o'clock, I run this scheduled job where I create my aliases because these are multi-member files. And I want the most recent one to look at the data for today. And so that's what this Dawn M alias is these are aliases for my various database files. And we track the weight buckets are tracked globally at the system level as well as at job levels, but I'm using the system level. So we've got these aliases that are set up every day at midnight. So when I come back here and I do this little select on this alias, I am getting the most recent value. So here's our job weight. And it's documented in the files so that we know bucket 9 is disk write time and bucket 5 is page fault time. And you can pull these out, do a little math to get them into seconds. And then the secret here for making this work is to order by the interval number descending. So we get the most recent interval and we want one row. And so then that gets us the most recent amount of time in our weight buckets. And so we can monitor these. You're going to see these at all times. It's kind of like CPU. What you want to know is, do I have an unexpectedly large amount of one of the weights? And then that's a flag that I would want to go look at my system in more detail.
I want to point out, Dawn, that you mentioned how much you love NewNav. Everybody has NewNav. It's browser-based.
Mm-hmm. Yep. Everything I'm showing here today, everybody has. Just be current on PTFs.
they've done a great job.
Yeah. So this was kind of a little bit of a deep topic, but it's just something that, listen to the replay or, capture what I showed you here. Because, for example, I've got a client where they have unexpectedly large amounts of gate time that surface, and we're troubleshooting it. It's intermittent. And so we can monitor it. They're actually using Prometheus and Grafana. They can build in automation. So if the gate wait time gets above, 15 seconds or whatever the threshold is, they can be notified. So then they know to get on the system right away and start their investigation. It's great for intermittent issues.
What would precipitate this? Just a slow running job or something that takes long to initiate? Why would you want to look at this information?
So usually it's for troubleshooting, and it's for troubleshooting intermittent issues. For example, I mentioned contention on a user profile. If you were doing too many creates and deletes and, oh, it happens every day at 11 o'clock, let's capture it and see what's going on right now. Gate contention can happen on changed journals. Maybe you're depositing too many journal entries and you've got to change your journal and you get things backed up. There's all sorts of reasons. Object lock contention might be one. Maybe you've got conflicts with objects that are trying to be updated, but it's an intermittent thing and you don't know when it happens. And so by seeing it, we can see when it's happening without babysitting the system, looking at everything constantly.
And it's looking at history, so you can really go back and use it for debugging, things like that.
Yes, yes. So this is in collection services data. So you've got that. And the other thing that I have going on in this petition, if we get in here, I have set up, so collection services is great for scoping out the problem, but if you want to do diagnostics, you need job watcher data. And I have set up using a little CL program. I run job watcher collections 24 hours a day. I keep 24 hours collections so I can go back and look at yesterday. So if something happens, I've got this detailed data where I can immediately start doing diagnostics. And this will get me things like call stacks and SQL statements. And you can pretty much solve any performance problem quickly if you've got this data available to you.
And 24 hours is a reasonable amount of time, you think?
24 hours is not long enough, but that's what I'm only doing that for on this demo system. In real world, I like 8 days. So you can look at last week and compare to this week. You can do this all with Navigator, and you have to write a little CL program to continuously collect this data. The program is trivial. And we're not going to talk about it at all other than this one comment. There is a product called iDoctor that will do all of this for you. You get to pay money for that, and there's all sorts of challenges with it. You can do this all now in Navigator. I'll show you how trivial this little program is. This is my program, and I mean,
it is
this is it. It's 32 lines, including all the blank space.
Wow.
It's, you just need to know how to do the submit job and how to, so if anybody wants a sample CL source, we can make that available too.
Perfect. And this runs every day, you said?
It runs continuously.
Oh, continuously.
It'll run until my subsystem is ended. So if we go back over here, I have 2 jobs. This Dawn Job Watcher, which is the main driving job that just submits the job to do the job watcher collection and waits for an hour, and then it does it again. And then this job, which is actually collecting the job watcher data. This just will run forever.
Couple of more posts in the chat. I'm going to rephrase one of them, and the person is asking, how many people do you think right now are going into performance right now? Like in the next gen, that is. Is there a need? Do you see a real need for this, and do you see people going into this space, or is this a real opportunity for somebody to get into?
There are not enough people with deep performance skills or even shallow performance skills. There are so many people that don't even know what we've got available here in Navigator with the Investigate data features. You mentioned at the beginning, Charlie, when I work with shops, I am doing everything I do, I want to share. I want to train. I want people to know how to do this because I'm not going to be doing this forever. And we need to make these features more widely known. And if nothing else, what I highly recommend that everyone does is every morning go into Weights Overview and look at your signature from yesterday. And let's look at this. Let's go look at QPFR data, which is where it is this is old historical data. Let's look at yesterday. Every morning, go in and look at yesterday's signature. And this is uninteresting. Well, look, we had an anomaly yesterday. Maybe that was me. I don't know. I was prepping. But you're going to see what your normal signature looks like, especially for a business. That signature looks the same almost day to day to day. And if something goes wrong, it's going to jump out at you. And if here everybody has collection services running, you can start and do basic troubleshooting. And so for here, all right, what was happening yesterday? I can go down and I can do various drill downs. And this is why I said names matter. These groupings, names matter. So let's go look at this by generic job. Let's get a hint as far as what was using all that CPU yesterday. I don't know. I haven't looked at this. And these drill downs don't take too long to load. And we always have to go like this to zoom in. Oh, it's QZD ASO init. Well, that's not very helpful. So let's go back. And this is why when you know your environment, oh yeah, it does that when you go back. It doesn't remember the filters that you used. I'd like it to remember the filters that we use. Okay, so let's try. So most people will know your system, so you'll know the right drill down. So let's just go look at this from job current user profile. Who was doing this? And so this is the user that was running in those QZD ASO init jobs. And, oh, it was Carol.
Carol Woodbury.
Yeah.
We'll have to send her an email or a text.
Well, I had Job Watcher started yesterday, so I could go look and find out what she was doing. So the Job Watcher data will show me call stacks and SQL statements, and I could go find out exactly what Carol was doing yesterday.
So without going too far off on a tangent, but there's quite a few messages in the chat that I think I simply can't ignore them. And yeah, I'm going to try to summarize some of these. So if somebody, because I see an opportunity here for several opportunities here to get into this space. And how do you get into this? This is completely off the discussion, but how do you just start learning? You do it, right? You just get into it.
Yeah, so you start by using the tools, and get familiar with the interface. If you understand your system, do the drill downs, look at the signatures. You can everything we can drill down. I have there's an old how to use the Performance Data Investigator article, but it's with old Heritage Navigator. I probably should redo one, and you ask questions, but the best thing is just to use the tool. It's free, it's part of your system, and then you can really mess things up if you don't have your scroll bar is not working right, or your mouse misbehaves from time to time. But if you want to understand a graph, IBM gives you all the SQL behind it. Now, this is maybe not for the faint of heart, but if you want to understand these things a little bit better, IBM documents all the collection services files. And you can go okay, what is this field? What is this? Oh, these are weight buckets. And then here's my job type, my job subtype. You can go find out what all these fields are, and it can give you a clue as far as what does that chart mean. So I'll tell my story about how I got into performance. I mentioned earlier on, I started my development career in communications. I worked on X25 and Ethernet in the early days of the AS400. Well, V3R1 and V3R6 came out. And there's some people in the phone or meeting here that probably remember how buggy V3R1 was. Worst release ever put out by IBM Rochester. I was given the assignment to fix the communications problems. Which is a very difficult assignment. It took me years, but that's what got me into performance, because communications error recovery would crater the system. And that was I worked on that for many, many releases. We finally had the final fix in V5R3 when we made multi-threaded subsystem monitors. Long story short, it just started by doing it, and you had to learn, and we didn't have these tools available back then. With these tools that we have available to us today, it's a great opportunity to learn about them. It takes years. I mean, I started working on this performance-related issues in the late 90s. And that's kind of been my career since. So it isn't a skill you develop in a year.
Right. And the other side here is that maybe, AI can help with some of these repetitive things as well.
Yes. Yes. I am familiar with a company in Poland that has a product called iRaise. So that's an interesting product I'm watching. They use collection services data and have machine learning built in to learn what a normal system behavior is and looking for anomalies. So that's the one I'm watching. I'm kind of excited about what they're doing.
And it would take corrective action.
Possibly, yeah.
Yeah, that's the whole real AI. So some other questions that popped up while you were speaking, Dawn. Two of them are specifically mentioning eye doctor, and I guess they were asking, is eye doctor still a viable tool, or has this kind of replaced it, or where does eye doctor sit in this space?
So if you're doing really important diagnostics, unfortunately, eye doctor is a must-have. Job watcher data here with Navigator is high level only. You can't get to the level of detail that you can with eye doctor. And eye doctor has a lot of features that are not found in collection services or job watcher here in Navigator. I find, though, that from a day-to-day perspective, 80% of this can be done in Navigator. Collection services, I rarely use eye doctor for collection services. I find Navigator's investigate data much more pleasing, and I like much more usable. Eye doctor is one of those tools that if you have to use it, you need to use it every day or frequently, or it's just a complicated tool. And it has install requirements that, oh, I don't have it, I need it. Oh, I can't install a library on my production box. You got to go through change management. It'll take me 6 weeks to get that done. So there's some complications that are eliminated with the Navigator performance tasks.
I think good advice for anybody, just who, if you're really interested in getting into this space in any meaningful way, I would just start at the beginning and just read all your blogs, Dawn. I mean, each one of them is just chock full, and they really give a complete, a really deep understanding of what's going on in your machine, piece by piece.
Yeah, and I've thought about writing a book, but this is so visual that a book becomes static and stale. It's like a lot of my older blogs. The screen captures really are in need of update now that we have this new Navigator. I've thought about doing a series of little videos, and it's just like, oh, I don't like taping videos, but I do have on my mind of somehow putting what's in my head into a form that others can get at on demand. Because I'm not going to do this forever, and there's a lot of information that I think would be valuable to get out there.
Absolutely, absolutely. So before I get into the next topic, so Dawn, when people contact you, when a customer contacts you, let's say for the first time, I mean, when you don't know what you're really walking into, what is your go-to? Is your go-to you start collection services just to get an idea what's going on? What's your very first thing to see if they have something already?
Excellent question. There are two things I do. One, we go to collection services configuration, and we make some adjustments. This is always running. If you've turned it off on your system, turn it back on. Don't turn it off. The only thing it takes is disk space. Otherwise, it's invisible as far as what it does. But as shipped, the collection interval is 15 minutes. We want this to be 5 minutes. Okay. The rest of these on here are probably okay. And then the retention timeframes these are the default okay. They're generally okay. In certain cases, I do like to make the database file retention bigger than just 10 days. But the key thing here is the interval. Make this 5 minutes. It's much more, you get better results. The other thing, don't change this. Keep this standard plus protocol. I have a blog on this, by the way, collection services configuration. There's one out here on this. System monitor data, this is optional. We'll talk about system monitors in a little bit. But turn on historical data. This is off by default. You want historical data to be turned on so that you can look at trends. And we're going to talk about how important trends might be. The collection interval default is 60 minutes. I like to turn it down to 30 minutes. And then the rest of these, you have to specify your retention. And I'm saving data on here for 33 years. And the file is small. I think it's under a gig. And I'm keeping detailed data, which is top contributors, so I can do drill downs for 2 months. So data retention, I would keep the summary for a minimum of 2 years. I like 3. And the detailed data, I like keeping that as long as I can, or I like 2 months, but you can see you can go out to a longer period of time. This, starting with 7.5, new installs have this turned on, but most of us do upgrades. So this is off by default, so turn that on.
Does it really matter what the application mix is and what environment, if it's open source, if it's RPG, for example? Does that have any impact on everything we're talking about right here? Or is this what you're talking about right now is good for any shop?
Good for any shop. Good for any and every shop. And it collects, it doesn't matter what the application is doing. We'll get a jobs run wait signature, and then you can always look at your performance signatures with this. So the big thing with the ship default is just fine tune those parameters I mentioned.
So we did mention PDI a couple of times, and I know you've even shown a bit, but you want to do a little more of a discussion on PDI, Performance Data Investigator?
So that's this investigate data task. And we can see any data that has performance, any library that has performance data in here will be listed. I have this demo data just because it's more interesting to look at. We talked about weights overview already, but just a little bit of, so I always like starting with weights overview. And then if you see a problematic time frame, the methodology to investigate collection services data is always the same. So let's say I want to find out what this lock contention is about. We select beginning and ending points. You always want to have a beginning and ending point for your drill downs. The color of the bars matter. So if you click the gray, when we do the drill downs, we're going to sort by the gray. If you were to click on the red, we would sort on the red. So it's the wait time of interest. What you want to investigate is the color of the bar that you click on. And then we do our drill downs, which is these groupings. We'll take this one. Let's just do by subsystem, since I talked about the importance of subsystem configuration. And if you have something, if you've done subsystem configuration and have done a good job of that and have grouped application jobs all together in the same subsystem, if you have an issue, just do weights by subsystem. It's one of the slower charts to load, but it'll come up with in order by subsystem for the thing that you're investigating. And you can see, oh, it's the Dawn May subsystem where all of this was happening. And right then, if you have done that subsystem configuration, that one drill down, that 3 minutes of your time, you already know where to look. That's why it's so effective. And then from here, we're looking at a subsystem. We can go looking at the jobs or tasks. We can look at the signature of the subsystem over time. So 4 means over time. How long did it last? By is top contributors. So let's just go look at the top contributors to what was going on in that subsystem. And this is a really contrived little test. I just wanted lots of colors in my charts. And it'll show me all the jobs that were running that contributed to it. And you can see I was doing a retrieve dir info. I had loop jobs. They were all doing the same thing. Display object description, all to the same output file, which is why we have the lock contention. When only one of these jobs can actually update the output file for that display object description at a time, the other ones were delayed. We had to wait on that object lock. And doing some database queries, just a mix of stuff to get pretty colors.
Is there any way you can go, you can do a deeper drill into one particular job on here that can show me more information about one given job?
So with collection services data, we can't go much further than this. Job Watcher data can. So let's demo data. Let's turn on Job Watcher. I'm not going to go very far with Job Watcher because Job Watcher, it's works, but it's slow. And IBM knows. They promised me they're going to work on it. Demo. Oh yeah, let's turn off these. Let's just get to the Job Watcher. So we've had weights overview with collection services. We also have weights overview with Job Watcher. I checked the collection services one by accident. I need to select the Job Watcher one. And like I showed you the weights overview with the collection services data, the chart's going to look exactly the same. Now we've got a bunch of seized contention in this one. But these intervals are 5-second intervals. I think they're 5-second intervals. What did they graph? I don't know the time. The times aren't granular enough in here. I'm having trouble seeing them. They're 10-second intervals. But from here, with the seized contention, if you take 3 of these, I'll just quickly, and we can go down, but we want to go by thread because call stacks are thread scoped. And if you can look at an individual thread, I'll see if I can bring up a call stack here. Yeah, they sort by idle wait. I think they sorted by dispatch CPU, and this didn't give me what I wanted. Anyway, oh, here we go. So now we can go look at this one, and then we get our weights for one thread. And the weights for one thread gives me this one job over time. Now here's the magic of what we can get to. Let's see if it'll show us. When we get down to a thread over time, we get this interval details. Now we're getting into some detailed information here for performance. Let's see if we captured one. It's uninteresting, but we have our call stack. And if you had an SQL statement down at the bottom, there'd be an SQL statement. There isn't one here. But we can go, and then we can go look at our next interval. This is where it gets really slow. And that's why you have to use iDoctor if you want to go looking at call stacks, because going from one call stack to another here in Navigator is painfully slow. But it's an example of what you can get to. And if this was a database server job, this would be much more interesting. This is just related to reclaim resources.
You know, as you're showing more and more of these different things here, Dawn, it's becoming even more. I mean, I've seen you in action at shops, but it's becoming even more obvious. If you're looking at this from a pure developer's perspective, and you're not looking at what's actually happening under the covers, you're not getting the full picture, and you're trying to identify what's going on. And this information is really the nuts and bolts of what's going on under the covers, I think.
Yes, this is what's going on under the covers. Let's see if we can. And job watchers and collection services, they're imprecise because they're sample based. They're not a trace. So that every interval, so like with job watcher, every 5 seconds or 10 seconds, it takes a sample. But think of the developers in Rochester are brilliant. Think of what this is doing. This is taking of every job that's used CPU in that 5-second time frame, getting all of their call stacks. And you might have 1,000 jobs, 5,000 jobs. And it doesn't always get them. It might not be able to capture everything, but it's unintrusive. You don't even see the job watcher collection show up in your performance signature. It magically does all this. It's just disk space that you have to care about. It's amazing this is something that IBMi does that no other platform in the world can do. This is a major differentiator for us. And being able to have these tools at our fingertips is really powerful. Everybody has Job Watcher too. It used to be you had to pay for it, but not anymore. It's included with every system has it.
Wow.
Yeah.
That is amazing, actually.
It's amazing. And yeah, we're kind of off deep into some things on this when we start looking at this level of information. And you don't always have to go there, but it's good to make sure everybody's aware of what the options are if you need to have to get to troubleshooting. IBMi is amazing at how well it performs under adverse conditions. I have seen so many systems that are shipped defaults that are not appropriate in today's world, and you don't even realize that, oh my gosh, it's horribly inefficient. It's doing the work beautifully. But that's why a lot of people don't even need to worry about performance. But it works until it doesn't. And then you know how the curves can be. Yep, we're working along okay, and then you hit that knee of the curve, and then you've got problems. So being aware of what your signatures look like to identify, do I have a curve coming in that I've got to address sooner rather than later?
So, do you think those who are on this meeting right now and those who are going to watch the video replay, you think that they would be surprised in a new environment if they've never done any of these things before? Might they be surprised what's actually going on under the covers, or they had no idea? How often do you see that where you hit these things that are so surprising? I didn't know that was actually happening.
Yeah, so there seems to be like three groups. There's people that know about these tools and use these tools. There's a small number of us that, this is the world we live in. Then there's a pretty, I'm trying to make this a bigger group that's aware of them and they look at it when they have a need. But there's a far too large audience that doesn't even know this exists. Speaking at Common or at Tech Exchange last week, I did a performance data investigator thing. And how many of you have used this? And half the hands went up. It's like, it should be everybody's hand should go up that I know about it. And I've gone in here and I've looked at my performance signature. And like I said earlier, if you just look at this weights overview for each day, it takes 2 minutes. And then you can just know, is my system behaving as expected or did something unexpected happen?
Yeah, but clearly it's also, using the tool is one thing, but knowing how to interpret the information is where the real
Yes.
expertise comes in. Certainly.
Yes. I'm actually, I was just talking with the folks at Common. I think next year at Power Up with the performance sessions I'm doing, I'm asking that they're all re-recorded and put in the content library. So if you're not familiar, Common has an online content library of about 500 hours of recorded sessions. I'm going to make ask that my sessions from Power Up next year be recorded and made available. You just have to have a Common membership to get to them.
Now that's a bargain.
Yeah.
500 hours of
And I do one of the sessions I've been doing is how to understand your performance signature, which goes through exactly that. What do these charts tell me? And on that, I have one that I really want to show because I see this all the time. So, oops, I know it's Dawn Data 7.4. It's hard to do demos because we don't want Job Watcher, we want collection services. And we want, I don't know why there's 2 in here. That's the one I want. But what I wanted to talk about this. This is memory tuning goes back to, release 1. And what I'm seeing a lot of is pools that are at their ship defaults. Now think about when we go to, I see this logged me out. This one didn't. If we look at work shared pool, this system is at the ship defaults. We have our 4 pools. And actually, there's been some tuning in here. Spool Interact is now limited to, made smaller, but the maximums are still in place. And Spool is made smaller. But most shops have these all at their ship defaults. I think Interact is 10%, and I can't remember what Spool is. Well, the problem with that is these ship defaults were great 30 years ago. When you have environments where you're moving from interactive green screen applications and going to web-based applications or database access applications, these default memory pool tunings are not appropriate. And there's 2 charts in here that can help you. Memory pool sizes and fault rates, how the methodology I use is I open that one in a new tab. This is the only place we can get a chart in a new tab. And it will bring up my memory pool sizes and fault rates. And load. You can see we have the four pools, so we can see here's base. We had this giant fault, which is interact, so we take it off. So we had a big fault in the interactive pool, and we can see the performance adjuster moved memory over to the interactive pool and then slowly moved it away. And this is contrived because it's not real world. But we can also then look at this one, memory usage by pool. And this has the magic graph. These two graphs, you can use these to bring some science and data to your memory pool tuning. We don't have to guess anymore. We don't have to sample, work status to see what our fault rates are and guess. And in this one, this is the usage by pool, but the bottom one, way down here at the bottom, is unallocated pool space. So if we deselect all these and we put it to interact, oh, look, we moved all this memory over. So we can see over here, we moved the memory. It got moved, it never got allocated, and then it got moved back to base. Performance adjuster doesn't take into effect if memory is being used or not. So it moves it over, it's not used, then it moves it back. What I'm seeing happening is with ship defaults, the performance adjuster heavily favors the interactive pool. And if you've moved from an interactive applications to web-based applications and haven't adjusted your tuning parameters on interact, you're wasting tons of money. All the money, yeah, but memory, because it gets put in the interactive pool, it's not being used, but performance adjuster leaves it there because there's activity there. So use these two charts, pool sizes and fault rates. If you have more than the ship 4, you got to go down to the second chart to see all of the shared pools. And then there's another one for the faulting rates with all of the shared pools, and then unallocated pool space. And that shows you which memory pools have memory that's not being used. So it can really help fine tune those min and max sizes on work shared pool.
Dawn, with all this tuning, or this potential tuning that could be done, and how things are shipped by default and possibly not configured, correctly for any given shop, when you have a properly tuned system, it's almost like a free upgrade.
Yes, I've worked with shops where we make a few tuning changes, and that's all it took to fix the sluggishness. There's so many knobs. And if the knobs are all at the default and they could be set better, doing that little bit of configuration can take a system from sluggish to wonderful. I have a little story. Got involved with the shop that said, our system is just sluggish. It's just, how help us? So just weights overview, show me your weights overview. And I saw this layer of CPU queuing. So if we go back to, see now, always remembers, we talked about this in the Navigator Advisors meeting on how we remember this or we don't remember this. And we want to go back to weights overview. Oh, come on. Sometimes, and don't sort on the column. Here it is. Well, we got it. But we saw a layer of CPU queuing, this purple. In this example, this is due to a workload group, but they weren't using workload groups. So why do I have this latency? My CPU utilization was like 30%, but I had this layer of purple everywhere. And what it was, actually, there's 2 shops I found this. What it was is these shops were heavy users of Java. And the Java garbage collection threads algorithm stinks. So the more processors, the more cores you have on your system, the worse the algorithm becomes. So for Java garbage collection threads, let's say you have 2 cores. So you've got 2 virtual processors and you're running on power 8 or later. So you've got hardware simultaneous multi-threading of 8 hardware threads. 2 times 8 is 16 minus 1. That's your algorithm. So number of VPs times 8 minus 1 is the number of garbage collection threads you have. Well, this system had 4 cores. So 4 times 8 is 32, so minus 1, 31 garbage collection threads for every JVM. They had hundreds and hundreds of JVMs because of how their application was working, and they had these short-lived JVMs that would fire up and go away. So every time a JVM fired up, we start 31 garbage collection threads, and then it dies. We changed that. We can set it. It's a property XGC threads. We took it to 2 because it was a small system, fixed the problem. It was just all this overhead of starting all these garbage collection threads, 31 of them, when we never were running garbage collection on these short-lived JVMs, took it down to 2, and all the sluggishness went away. The CPU queuing went away. So another example of a default parameter that if you're a heavy user of Java, you want to make sure you set that appropriately.
While you were speaking, Dawn, there's some additional notes being put into the chat, and some of them referring to like old code and specifically around SQL, things like that. And do you typically keep an eye on the plan cache for SQLs? Is that something that would be in your wheelhouse, or is that more a designer question? And also, there was some discussion here going around. I know my answer on it. I know the official word on it, but as far as the number of times you IPL the machine to reset caches, things like that, do you have any particular thoughts on that, or how do you?
Oh, yes, I do. Yes, I do.
Okay.
So in PDI here, we have a collection of charts called database. And I just happen to know plans. So there's this perspective called plans detailed. And let's take a look at that. This is yesterday on this Common One system. Uninteresting, but this is actually quite interesting. So this tells us how big our plan cache is. So our plan cache must have a max size of around 6 gig. We can see what the actual size is on the yellow line. And then we see this blue, which is plans pruned. What I'm seeing quite a bit is, I like to look at this chart because it kind of gives me a view of how well is that plan cache working. Because if you see a lot of blue, plans pruned are valid plans that have to come out of the plan cache to make room for new ones. And so the removed ones, red, is, yeah, they're obsolete. We don't need those anymore. But pruning takes plans that could be used again and makes room for other ones. And so something happened on this system. This is an uninteresting chart. This is not a real world chart. And so here we see plans created and plans removed. Again, demo system, this isn't very interesting. But this can kind of give you a view of the health of your plan cache. And so if you've got doing a lot of SQL and you see my plan cache is very small at 512 megabytes, check your temporary storage. Maybe you need to manually make it bigger because your hit rate's higher, but you're having a lot of pruning going on still. Or maybe you need to make your hit ratio higher so the plan cache will grow bigger. But this chart can actually give you some basic insight into how your plan cache is working. And then the other thing that you can get to from here is your temporary indexes, your MTIs. And again, uninteresting, but if you see hundreds and hundreds of MTIs out here, maybe you want to make some permanent indexes because that leads into your IPL question. Because all these MTIs go away when you IPL. Your plan cache, everything that's been stored away in your plan cache is lost when you IPL. I know shops that IPL weekly, and I'm like, why are you doing this? Because every Monday their performance tanks because they have to rebuild all of this temporary database information. The plan cache has to get populated. The MTIs have to get built. And Mondays are painful when you IPL on Sunday.
And then back by Friday, it's back up to normal or good speed, and then it gets reset again.
I have looked at it. To me, it takes about 2 weeks to get back up to full speed. Because I've got a shop that I actually convinced them to go to monthly IPLs. And when we look at these charts, it takes about 2 weeks to get to a steady state for that environment.
Why not just bring the machine down for planned maintenance and
Bingo.
Not IPL at all?
That's I think quarterly IPLs for maintenance is a good window. I think monthly is even more than we need to do. That's just my opinion. We could get into a debate on that. But one of them, I heard, well, we think things get corrupted, so we want to IPL weekly. It's kind of like the Windows mentality. Well, let's just restart just to make sure we don't have problems. Typically on IBMi, you don't have to do that. And if you have an issue, it's better to solve the root cause than rely on an IPL.
Yeah, I've spoken to many other experts, I should say, in Rochester, and that's that's perhaps there might have been a time when that was a valid discussion, but any recent discussions I've ever had with anybody in Rochester, the answer is
Yeah.
always the same, and it's completely in alignment with what you just said here.
I'm just going back to look at this. Yeah, uninteresting. So this makes me want to go over here and bring up the SQL Performance Center. So when I started doing my own work, I was a system generalist. I wasn't a database expert, but this is a database machine. And in the real world, you have to deal with database performance. You can't separate database performance from IBMi performance. And so we can see our plan cache is 5 gig auto. Oh, here's why it's so, our hit ratio is only 87%. And the goal is to be 90%. So that's most likely why that plan cache has grown to be as large as it is, because the hit ratio is so low. But it's a demo system. We're never going to have a good hit ratio on this partition.
But it goes back to what I said earlier, knowing where to look and how to interpret these numbers are really the
Yep.
So
yeah, it's exactly. What does plans pruned mean? What does plans removed mean? And there's some documentation, but there is not extensive documentation. And on any of these graphs, there's no help. The best you can do is you can look at the SQL and kind of see what the metrics they're getting at from collection services.
So what we've been showing so far is applicable for any size shop, but let's get into SMP a little bit. These touch on it, and who would typically be using symmetrical, and who would be parallel? Who would be doing that? What size shop, or is there any reason why someone should consider going that direction? Things like that.
So yeah, DB2 SMP, simultaneous multiprocessing. It's an option of the operating system that you used to have to pay money for, but now you can get it for no additional charge. And so what the SMP is good for is reducing the wall clock time of long-running queries so that they will run shorter. They're going to use more CPU because they can run things in parallel. Like you can do index builds in parallel. You can do table scans in parallel, where you've got multiple different threads all working, coordinating together to accomplish the task in a shorter amount of time. So it reduces wall clock time, but it will increase your CPU utilization. And I have seen abuse of this product because they install it and they turn it on system-wide. And that lets any arbitrary query be enabled for parallelism, multiple threads executing the query. There was one shop, they had 12 physical processors, so the number of cores plays into the aggressiveness of the parallelism. They had jobs that were using 48 threads to run queries during core business hours. Temper that back. There's a set of controls so that you can control that parallel degree. You can control it on an individual job. So yes, this long-running month-end process, I want that thing to run in parallel, but everything else I don't really want to allow the system to use extreme parallelism for, because it will increase your CPU utilization.
And it was some mention, I have it in my notes, but it was already mentioned about the feature in 7.6, the parallel updates and deletes.
Yes. Yeah, they had some enhancements in 7.6 for more parallel operations, and 7.5 they added more SMP controls. So you can set, a query has to run at least this amount of time before it can be considered for parallelism. Or my CPU utilization has to be below a certain limit, otherwise I won't use parallelism to protect the system as a whole.
I guess it goes back to the original question. If you were to go into a shop and you saw something, what would be the trigger or the impetus for you to recommend implementing this?
So if you see a CPU-bound query that's running single-threaded that takes far too long and there's a need for it to run in a shorter time frame, that's a candidate to look at, see if SMP can help that particular query. Index builds, that's another one. I've got to do these index builds. Can I do them in parallel? And I don't like to see just turned on system wide, because you see too many little things that can be running with parallel threads, and you get this threading signature. Threads are lightweight, but if you have too many of them, that adds overhead.
Somebody put in the chat just now, we have S&P, our planned cache size is 33 gig, hit ratio is 84%. Does that sound reasonable to you, or is that something without doing into that?
I would definitely want to look into what's going on there and optimize things.
Hit ratio is too low?
The hit ratio is low, the cache is huge, but there are some environments where it's hard to do that optimization, because things like different library lists. I'm aware when, if I've got an environment where I have too many different applications and how do I get that hit ratio higher? Sometimes I do know of environments that can be a real challenge. So in that particular case, it depends.
So you've shown us so much here, and is there if a shop really believes, or if the team believes that they need a legitimate upgrade, what graphs or information would you provide upper management, for example, to make a real tangible argument that we need to get an upgrade? The current configuration just doesn't cut it anymore.
Yeah, so I don't have really good examples. I do have something here on Common One that we can talk to this, but I mentioned earlier, we want to turn on historical data, and that's where we get into graph history. So this is again under the performance tasks. Once you turn on historical data collection, we can get to graph history. And when you first bring this up, this is showing me the past 30 days of my CPU utilization. So if you were needing to, let's say you were watching your CPU utilization, you could use this graph, and I can't give you a really, let's just do this. Let's look at this for the past year, and we'll look at our CPU utilization for each day, so it's averaged for the day. Again, this is an uninteresting box, but in a real world, if you see your trend going up and you're getting up to 80, 90%, you might that's a way you can say, oh, or look at our CPU utilization over the past year, it's been growing. And with CPU utilization, you have two choices: add hardware, so you need more processors or a system upgrade, or spend people money and optimize your code to make it more efficient. Those are the only two options you have to address the high CPU. People money or hardware. You're going to spend money one way or the other. And a lot of shops are fine with just saying, yep, let's just do a hardware upgrade and add more CPU capacity. So you would see a trend that increases. Then what you can do is, and I actually did this prior to the call. We're going to go back and look at this. So I've got 3 years of historical data out here. So we're going to look at this from October, let's say 11th of 2022, because I happen to know there was an upgrade done. And so we'll look at October 12th of 2023. So we're looking at this, and I want to do this. I can go down to, I'll take it down to 12 hours. So we can customize what we're looking at and do a refresh. And so this can also be used to show the benefit of your upgrade. And so this was, I think we were on Power 7, I can't remember for sure, and we did an upgrade to Power 9. And so we can see at this point in time, early January 2023, how our CPU utilization, and of course this is a demo box with almost no work on it, was averaging around 5%. We did the upgrade and now we're down to like 2%.
It's never, wow, it's a fraction of where it was.
Yeah. So in the real world, if you do an upgrade, if it's a hardware upgrade, you can show the benefit. We did this, here's where we were, here's where we are, this is the benefit, we've got a lot more breathing room. There's other charts in here, and I can't demonstrate it because I don't have any specific time frames, but let's say you did a disk upgrade. You went from, God forbid if you're still on spinning disks, to SSDs, and you could go look at your disk response time, and you could see the dramatic improvement in your disk response times if you do a disk subsystem upgrade. So there's a few charts in here that can help you show where I was and how I was suffering, and I did this upgrade and how much better I am for doing this. The other thing that I like about this is I use historical data. So if we come back here and just do, the last month, and do a refresh. Sometimes I use this, oh, look, there was an anomaly, last week. I missed that somehow. It was out of sync. It's sometimes you can find unusual signatures in historical data that cause you to take a deeper look as well.
Wow.
Oh, and there's one more. I know we're getting way out of time.
No,
So
this is you have our rapt attention, I can assure you.
So this is long term, what's my trend over long periods of time? I mentioned I like 3 years just because of this reason, but how do I notify what's happening right now? And that's where we have these system monitors. And so I've got some demo system monitors. These are real time. And so if I do visualize system monitors, this is showing me what these metrics are minute by minute to the most current minute. So we can see what's happening. This is today. We can look at the full day. We can go backwards, but this is where we are now at 3:29 Eastern time. These automatically refresh every minute. But it's not just the graphing with these. Let's just go look. Which one's, oops, here's one. If we look at the summary, we can build in automation. And so for any of the metrics, we can put in triggers, and then we can build in automation. So here, this is disk response time. If my disk response time, my read disk response time gets over 8 milliseconds, I send a message. You could send an email, you could send a text message, you could call a program to notify. So you can build in automation. So you can set up these monitors so you don't have to babysit your system on an ongoing basis. If my CPU utilization hits 75%, send me a text message and so I can be alerted to it and I don't have to babysit the system. And this is all based on collection services data too. So it's the same foundational data that does these system monitors as well. So we got the whole suite of tools right here in Navigator, all for every shop.
Huh. So really large or small, there's really, if you have somebody who understands how to get into this, this is something that you highly recommend everybody to take a look at.
Yeah, no, there's a lot of third-party monitoring solutions out there. Those monitoring solutions are often more sophisticated. They've got more features. But if you just need basic monitoring for a set of metrics, if we go into properties, it's easy to add. The list of metrics is static. You can't customize what you've got, and I don't like how this interface is all smushed together. But you just take the metrics, set your thresholds, build your automation, and so for getting started or for some simple notification, system monitors can't be beat.